Right now, a piece of metal made by human hands is hurtling through the frozen void 15 billion miles away, broadcasting a signal powered by less energy than the light bulb in your refrigerator. And somehow we are listening. By the time Voyager 1's signal reaches Earth, it is a billion times weaker than the battery powering your digital watch. It completely breaks our everyday intuition of physics. How do you catch a whisper in the middle of a roaring cosmic hurricane? Scientists around the world are genuinely baffled by the resilience of this ancient technology. But a growing faction of astrophysicists warns we might be pushing our luck. So, how exactly does NASA pull off this impossible feat every single day? Let's ground this in reality first. On Earth, if you walk out to your driveway, you probably lose your Wi-Fi signal. That's the inverse square law in action: energy spreads out and weakens rapidly over distance. In space, NASA uses radio waves traveling at the literal speed of light to talk to rovers on Mars and probes at Jupiter. It sounds straightforward, right? But here is where things get strange. When you extend that distance to billions of miles, the math starts to look entirely impossible. Stay with me here, because what you're about to see changes everything about how we understand our reach into the cosmos. If you love uncovering the classified, mind-bending truths of our universe, hit that follow button right now. We're welcoming thousands of new cosmic explorers to the Deep Space Secrets family every single day, and what I'm about to reveal next is exactly why. Let's go back to September 1977. Voyager 1 launches. Fast forward to today, the probe is so unbelievably far away that a command sent at light speed takes over 22 hours just to reach it. We are literally communicating with ghosts in the past. To catch these ancient signals, NASA built the Deep Space Network, or DSN. Imagine 3 massive arrays of satellite dishes strategically placed in California, Spain, and Australia. As the Earth rotates, one dish flawlessly hands off the signal to the next, creating an unbroken, planetary-sized ear. But recently, the scientific community held its breath when a massive glitch threatened to silence Voyager forever. So, how do they hear a 20-watt whisper from the edge of interstellar space? The secret is cryogenic cooling. The receivers on these massive DSN dishes are bathed in liquid helium, cooling them down to -452 degrees Fahrenheit, just a fraction above absolute zero. Why? Because atomic heat creates background noise. By freezing the equipment, scientists slow down the atomic vibrations, eliminating the static. It's like silencing a packed football stadium just to hear a pin drop on the 50-yard line. This elegant solution works perfectly. But it raises a terrifying new problem. Just when you thought you understood the system, here's a massive complication. Radio waves are painfully slow for high-resolution data. As we send missions deeper, the DSN is facing a catastrophic data traffic jam. Competing theories suggest we must abandon radio entirely. Enter NASA's latest wild experiment, DSOC, or Deep Space Optical Communications. They are now shooting high-powered, near-infrared lasers across millions of miles to a spacecraft called Psyche. But aiming a laser at a moving target in deep space is like hitting a moving dime in New York from Los Angeles. And what if someone, or something, intercepts this intense beam of light? This brings up a fierce, ongoing debate in the astrophysics community, and I genuinely want to know what you think. Are we solving the ultimate communication barrier? Or are we recklessly shining a galactic flashlight into the dark forest of the universe, announcing our exact location? Option A, we must upgrade to lasers to become an interstellar species. Option B, we are making a dangerous mistake and should stay completely quiet. Or Option C, you have a wilder theory, like using quantum entanglement. Drop your exact theories in the comments below right now. I read every single one. By the end of this video, you'll understand that this isn't just about talking to metal robots. This affects how we see our ultimate place in the universe. If we ever want to send humans to Mars, or probes to our nearest star system, Alpha Centauri, radio simply won't cut it. The time delay alone could be a death sentence in a medical emergency. That's why scientists are quietly laying the groundwork for the ultimate sci-fi concept, a quantum internet. If quantum entanglement can be harnessed, where two particles mirror each other instantly regardless of distance, we could theoretically achieve zero-latency communication across the galaxy. We could talk to another star system in real time, completely shattering Einstein's speed limit of light. But don't let the vast, terrifying silence of space discourage you. We are living in a golden age of cosmic discovery. Think about it, a species on a tiny blue rock figured out how to freeze metal to absolute zero just to listen to a 47-year-old probe flying through the dark. That is a stunning testament to human brilliance. Upcoming missions, like the Artemis Lunar Network and massive new space telescopes, are actively building the infrastructure for a true interplanetary internet. The mysteries out there are vast and intimidating, but step by step, signal by signal, we are bringing the universe into focus. The dark is getting a little brighter every day. But this isn't the only mind-bending cosmic mystery we are currently tracking. In our next video, we are exposing the terrifying anomaly recently spotted by the James Webb Space Telescope that is actively breaking our models of the Big Bang. And later this week, we'll reveal the classified deep space signal that NASA detected for 72 seconds, only for it to vanish completely. You will not want to miss these. Thank you for joining me on this journey. Remember this: the next time you look up at the night sky, between the stars, invisible threads of data are weaving the story of human exploration, connecting us to the absolute unknown. The universe is full of secrets, and we're just getting started. Stay curious, keep looking up.